2018 Connected Particles, question 4b. A movable pulley of mass m is suspended on a light, inextensible string between two fixed pulleys as shown in the diagram. Masses of 6 kilos and 3 kilos are attached to the ends of the string. The system is released from rest. 3 parts to this question. Part 1 is showing separate diagrams the forces acting on the movable pulley and each of the masses. Part 2 asks to find in terms of m the tension in the string, and part 3 you're asked for what value of m will the acceleration of the movable pulleys be 0. Okay, so I think the best way to do these questions, imagine that this guy is going down and the other two are going up. Because of the two strings, the accelerations will be different. So we call the acceleration, well, let's just do the forces diagram. We call this acceleration A, this one B. So this acceleration will be A plus B over 2. It's the key to this question. Okay, so let's look at the forces on separate diagrams. I have my 6. I have my T. I have my 6G. I have my A going in this direction. And from that, I can form my equation. T minus 6G is equal to 6A. Obviously from F is equal to MA. For my 3, I have B going in this way. I have 3G coming down. And I have T also going up. So in this case, I have T minus 3G is equal to 3B. Now my M. So I have 2 T's going up. I have MG coming down. I have A plus B over 2 also going down. So my equation is mg going down minus the 2 T's that are going up is equal to the mass, which is m by A plus B over 2. So what we do from here is write my A's and B's from the 6 and 3 kilogram masses in terms of the other two, and then we'll replace them in here, and that should enable us to simplify it down. So in this case, 6A, or A, just A, is equal to T over 6 minus 6G over 6, which is minus G. Here we have B is equal to T over 3 minus 3G over 3, so minus G. So if we fill them in over here, we're going to get mg minus 2t is equal to, probably best to bring this 2, put it under the m. So m over 2 times t over 6 minus g plus t over 3 minus g. Simplifying this down, we're going to get mg minus 2t is equal to m over 2 times, well, I have a third and I have a sixth of t, so that's 2 6 and 1 6, that's 3 6, which is a half, so that's just t over 2. And I have 2g. If we remove the bracket, we're going to get mt over 4 minus mg, the 2's will cancel, and on the left, mg minus 2t. So if I multiply by 4 to get rid of the fraction, 4mg minus 8t is equal to mt minus 4mg. And we're looking for, in terms of m, just double check, we're looking for, in terms of m, the tension. So we want t equals. So let's just simplify this down and to get t equals. So we're going to have 4mg plus 4mg. So we're going to have 8mg is equal to mt plus 8t. So factor out your t to get m plus 8 equals 8mg. So we're going to get t is equal to 8mg divided by m plus 8. Next part of this question, for what value of m will the acceleration of the movable pulley be 0? So the acceleration of the movable pulley is this guy. So how will that be equal to 0? A plus b over 2. Let's have a look. If a plus b over 2 is equal to 0, it would have to mean that the top is 0. So a plus b is equal to 0, or a is equal to minus b. So that's the starting point here. Then what we can do is we can equate a and b, or a equal to minus b, and we have these two guys here. So a is t over 6 minus g. T over 6 minus g would have to be equal to the negative version of b, which will be minus t over 3 plus g. Minus t over 3 plus g. So if we try and get t here, we can put it in here because it'll be in terms of g, and we'll be able to get an answer then. So t over 6 plus t over 3 is equal to 2g, and we've seen t over 6 plus t over 3 already. That's equal to t over 2. So t is equal to 4g. So over here then, 4g would have to be equal to the right hand side, 8mg over m plus 8. And we want to isolate m here, so multiply across 4mg plus 32g is equal to 8mg. Divide by 4 first. mg plus 8g is equal to 2mg. So if I bring, well, we have mg and 2mg, so therefore just mg will be equal to 8g. The g's cancel. I probably should have cancelled them earlier. So m is equal to 8 in this case for the acceleration of the movable pulley to be 0.